Question 1a says solve 14n greater than 11n plus 6. When it says solve, what that really means is to get n by itself on the left-hand side and get the values of n on the right-hand side. So the first thing I want to do is subtract 11n from the left-hand side. 14n take 11n is 3n. This is greater than 6. I have that positive 6 left over. And then divide by 3. 6 divided by 3 is 2, so we're left with n greater than 2. So we end up with the values of n being greater than 2. And that's the final answer there for 2 marks. Part B says, on the number line below, show the set of values for x for which x plus 3 is greater than negative 2 and less than or equals to 4. Again, think of the rules you use to solve equations. If we have an x plus 3, we want to get x by itself, we subtract 3. Now the difference here is we have two inequalities, so we have to subtract 3 from the left and the right. So negative 2 take 3 is negative 5, and 4 take 3 is 1. So remember, whatever step you're taking, whether it's to subtract 3 or divide by 3 or whatever, you need to do it to everything in that inequality. Just as you do in an equation, you subtract 3 from everything in the equation. Remember to do it for everything in the inequality. And then we have x greater than negative 5 and less than or equals to 1. You need to remember how to draw these sets of values on a number line. When it's greater than negative 5, we do an empty circle like that. And when it's less than or equal to 1, we do a filled in circle like so. And then we draw a straight line between them. And that represents the values of x. Okay, so that would be enough for 3 marks there for part B, and that was question 1 for 5 marks. Question 2 says, on the grid below, draw the graph of y equals 2x take 3 for the values of x from negative 2 to 4. It's really useful in GCSEs when you are given a straight line equation like this to be able to see instantly where the y-intercept is and what the gradient is. So as long as you understand that a straight line is written in this form, or can be written in this form, you can see that c, or negative 3 in this case, is the y-intercept. This is the y-intercept, or where the graph cuts the y-axis, and this is the gradient. 2 is the gradient. And that allows you to graph this line straight away between any sets of points. So let's go ahead and show what I'm talking about. So if the y-intercept is negative 3, we will have a point at negative 3. And if I know the gradient is 2, that means I need to go up 2 for every one across. So you can see actually the scales on this graph are different. So I need to go up 2 to negative 1 and across 1. So it looks like I've gone up 2 and across 2, but actually according to these scales I've gone up 2 and across 1. And then I have 2 points on this graph already. That's actually all you need to draw a straight line. And I need to, the domain is from negative 2 to 4. So I need to draw this graph from negative 2 on the x-axis. So it's going to be down here to 4 on the x-axis. So it's going to be up here. Okay, and then I just need to draw my straight line all the way across the graph. And I'm done. Now, do not extend it past those points if they tell you that it is between negative 2 and 4. It needs to stop at 4 and stop at negative 2. As long as you do all of that, then you'll get 4 marks for that question. So this is a graph of 2x take 3. And that was question 2 for 3 marks. Question 3 says Hannah is planning a day trip for 195 students. She asks a sample of 30 students where they want to go. Each student chooses one place. The table shows information about her results. So here we have the places: theme park, theatre, sports centre, seaside, and number of students: 10, 5, 8, and 7. Part 1 says work out how many of the 195 students you think will want to go to the theme park. Okay, so we're taking a sample. We have the total number of students being 195. We need to work out the proportion from the sample that said theme park and then multiply that by the total to get an estimate. 10 out of the 30 students said theme park. So the proportion is going to be 1/3. So we could just, show a little bit of working out here. I'm not sure you have to do this, but let's actually say, or let's use an approximation symbol here to see approximately 1/3 want to go to the theme park. And that's based on the samples. So if we want to work out an estimate for the total number of students who want to go to the theme park, we can do 195 divided by 3. 195 divided by 3, that's like 180 divided by 3. Anyways, you can use a calculator and you get 65 students out of the 195. So final answer there, 65. Part 2 says state any assumption you made and explain how this may affect your answer. Basically, with any question like this where you take a sample of a total number of students, you're assuming the sample represents the whole group. So you're assuming this proportion of 1/3 holds for the entire group. It might be different, of course. Like if you asked all the 195 students where they want to go, the proportion might not be 1/3. So basically the assumption is I assume the proportion of the sample represents the whole group. The actual proportion may be different. That's for 1 mark, and question 3 for 3 marks. Question 4 says a container is in the shape of a cuboid. The container is 2/3 full of water. A cup holds 275 milliliters of water. What is the greatest number of cups that can be completely filled with water from the container? For this question, you need to know that we generally assume 1000 centimeters cubed is approximately 1 liter of water, or 1000 milliliters of water. So that's a bit of information they're expecting you to know for this question. So the first step is we're going to find the total volume of the cuboid. So the volume is the length times the width times the height. So 30 times 6 times 19 to get the total volume. And we can go ahead and use a calculator for that. So 30 multiplied by 6 multiplied by 19, and I get 3,420 centimeters cubed. And then they tell us that the container is 2/3 full, so we need to find 2/3 of 3,420. So 2/3 multiplied by this amount. Let's see what we get for that. I get 2,280. So we have 2,280 centimeters cubed of water. In other words, approximately 2,280 milliliters of water. And then to find the number of cups we can divide this by how many milliliters in a cup, which is 275. So 2,280 divided by 275. So take that answer, divide by 275, and I get 8.29 and so on. So this is 8.29 ... And this is going to approximate to 8 cups of water because it says how many cups can be completely filled. So that 0.29 obviously wouldn't be a completely full cup. So this will be approximately 8 cups. So final answer there is 8 cups. And that was question 4 for 4 marks. Question 5 says AB is a right-angled triangle. Calculate the length of AB. Give your answer correct to 2 decimal places. So here we have an angle of 38 degrees and a hypotenuse of 16 centimeters. This is the unknown side. You need to think which trig ratio you're going to use to find this unknown side. So is it going to be sine, cos, or tan? Well, remember the sine ratio is the opposite side divided by the hypotenuse. So we're going to use the sine ratio here. And the equation that we can create is going to be the sine of the angle they give us, sine of 38, equal to the opposite side, AB, divided by the hypotenuse, 16. Once you've got this equation, you can rearrange to find AB. So AB is going to equal sine of 38 multiplied by 16. And then we can go ahead and plug that into a calculator. So I want the sine of 38 multiplied by 16, and I get 9.85 and so on, 9.85. And it says, give your answer correct to 2 decimal places. So the next digit was a 0, so this is going to round off to 9.85. Okay, so final answer is 9.85 centimeters. And that was question 5 for 2 marks. Question 6 says Sally used her calculator to work out the value of a number y. The answer on her calculator display began 8.3. Complete the error interval for y. So you need to think, well, what else could a calculator say if the display was saying began with 8.3? So let's type in something like this. So 8.30001. You could keep going, into infinity essentially. So it could be 8.30000 and so on, and then a 1 right at the end. So basically any value just above 8.3 is fine, or even 8.3 would be fine as well, right? So if the answer was just 8.3, you'd still have 8.3 on your display. Similarly, you could get 8.3999999, and it would still start with 8.3. So the minimum value, it could just be 8.3. The maximum is 8.399 recurring, and usually we write 8.4. So it's just less than 8.4. Anything less than 8.4 will begin with 8.3. And remember, it's saying the display began 8.3. So as I said, it could be 8.39999 and so on. And actually, my calculator rounds that to 8.4, which is kind of funny. But this could be your answer, and it would still start with 8.3. Okay, so that's your error interval there for question 6 for 2 marks. Question 7 says 360 pounds is shared between Abby, Ben, Chloe, and Dinesh. The ratio of the amount Abby gets to the amount Ben gets is 2 to 7. Chloe and Dinesh each get 1.5 times the amount Abby gets. Work out the amount of money that Ben gets. Okay, firstly I'm going to summarize some of this information. So the ratio of Abby to Ben, the amount they get each, so I'll write that as A to B. This is 2 to 7. And if I want to write them all in the same ratio, so Abby to Ben to Chloe to Dinesh, in other words, A to B to C to D, I need to think, how can I write these, the ratio of Chloe and Dinesh to Abby and Ben? Well, it tells me they get 1.5 times the amount Abby gets. So if Abby gets 2 parts of the ratio, they're going to get 2 times 1.5 parts of the ratio. So 2 times 1.5 is 3. So this ratio of all of them together will be 2 to 7 to 3 to 3. So that's relating Chloe and Dinesh to Abby. They're getting 1.5, the number of parts that Abby got, and it's automatically related to Ben. Okay, so that's the ratio of Abby to Ben to Chloe to Dinesh. And then we need to follow the process of sharing this amount into this ratio. So the first step is to count the number of parts in this ratio by adding them up. So 2 plus 7 is 9, plus 6 is 15. So there are 15 parts in this ratio. I need to divide the total amount, 360 pounds, by the number of parts. 360 divided by 15. Why not go to a calculator? It is a calculator paper. So 360 divided by 15, that's 24. And so each part in this ratio is worth 24 pounds. The question says work out the amount of money that Ben gets. He gets 7 parts of this ratio. So Ben is going to get 24 times 7. I should say Ben's share, not Ben. Ben does not equal 24 times 7. It's Ben's share. Okay, and this is 168. So final answer is 168 pounds for Ben. And that was question 7 for 4 marks. Question 8, part A says write 0.00562 in standard form. So when a number is in standard form, the first part is a number between 1 and 10. So clearly 0.00562 is not between 1 and 10. We need to multiply this by something. So if I multiply this by 1,000, this will be 5.62. And then to get from this number back to 0.005, you need to divide by 1,000. So in other words, multiply by 10 to the power of -3. So 5.62 times 10 to the negative 3 is your answer. Another way to think about that is we'll count the number of decimal places you move the decimal. So I've moved it 3 places to get to 5.62, and that is your index number. And if you're moving it forwards, it's a negative. If you're moving it backwards, it's a positive. So that's kind of a shortcut. Part B says write 1.452 times 10 to the 3 as an ordinary number. So when we're multiplying by 10 to the 3, that's multiplying by 1,000. 1.452 multiplied by 1,000 is 1,452. And that was question 8 for 2 marks. Question 9 says the circumference of circle B is 90% of the circumference of circle A. Find the ratio of the area of circle A to the area of circle B. Now there is a relationship here between the ratios of the areas and the ratios of the circumferences because all circles are similar, so we're talking about similar shapes here. But first let's think about how we can represent this ratio of the circumferences. So circle A, the circumference of A to the circumference of B. Now the circumference could be anything, right? We can let this number be anything. An easy number to use is 10 because 90% of 10 is 9. So we can represent the ratio of the circumferences as 10 to 9. You could let this number be something difficult, like you could let it be 3, and then you need to try to think what's 90% of 3, but there's no point in that, right? So use an easy number like 10, and then it means that the ratio of these circumferences will be 10 to 9. Easy to work out. 90% of 10 is 9. So then we can say the ratio of the areas, so the area of A to the area of B. By the way, I'm now writing it as a fraction, but this is the same thing as area A to area B. I'm just writing it slightly differently. This is equal to the square of the ratio of the circumferences. So this is the square of the circumference of A on the circumference of B squared. So this is 10 on 9 squared, which is 100 over 81. And that's actually the final answer. So the ratio of the areas is 100 to 81. And that was part A for 2 marks. Part B says square E has sides of length E centimeters, square F has sides of length F centimeters. The area of square E is 44% greater than the area of square F. Work out the ratio E to F. Again, for part B, we can use the idea that the ratio of the areas is equal to the square of the side lengths, or the ratio of the side lengths. So if we want to work out the ratio of E to F, we can take the square root of the ratio of the areas. So we can say the ratio of E to F is equal to the square root of the area of E over the area of F. And again, we need to think what this means if it says the area of square E is 44% greater than the area of square F. Use easy numbers. So if I write the area of E to the area of F, and E is 44% greater, well, let area F be 100. That means area E would be 144. Again, so area F could be anything. Just use an easy number such as 100 so you can work out area, or the ratio you can work out easily. So then this is the square root of 144 over 100. The square root of 144 is 12. The square root of 100 is 10. And this 12 over 10 is 1.2. Or actually, I should simplify that to a ratio because the question is asking for the ratio E to F. So 12 to 10 simplifies. If I divide both by 2, this is 6 on 5. So the ratio E to F equals 6 to 5. Also, I guess I could have also written 1.2 to 1. That would have been fine as well. But 6 to 5, I guess, is probably the more common answer. And so that was part B for 2 marks and question 9 for 4 marks. Question 10 says Mary travels to work by train every day. The probability that her train will be late on any day is 0.15. Part A says complete the probability tree diagram for Thursday and Friday. Okay, so if the probability that she'll be late on any day is 0.15, we can say the probability of being not late will be 1 take 0.15 or 0.85. And then the same thing for Friday. This will be 0.15 and 0.85. And the same thing down here, so 0.15 and 0.85. Part B says work out the probability that her train will be late on at least one of these 2 days. There's a bit of a trick with this question, but firstly, just be aware of the language here. It says at least one of these 2 days. So that basically means you can either be late on Thursday, or late on Friday, or late on both. So let's talk about the pathways we could take here. We could be late on Thursday and then not late. So you're still late on at least one day. You could be late on Thursday and late on Friday. That's still at least late on one day. And then you could be not late on Thursday and late on Friday. So these are all of the pathways you need to consider. So you could work out the probability of being late on Thursday, late on Friday, late on Thursday, not late on Friday, and then not late and then late. Or you can realize that if you work out all of these probabilities, it will be 1 take this probability here. So this probability of not late on Thursday and then not late on Friday. So all we actually need to do here for a little bit of a shortcut is to work out the probability of being not late both days and do 1 subtract that, because all of these probabilities need to add up to 1. These are the total outcomes, so they all need to add up to 1. If we just work out this one here, we do 1 subtract that and we'll get our answer. So what we're looking for then, as I said, we could work out the probability of late on Thursday or the probability of late on Friday or the probability of late on both. Or we could just work out 1 subtract the probability of not being late on either day. Okay. So these are equivalent. Okay, so we want 1 take the probability of not being late. To work out this probability, we have a 0.85 chance of not being late on Thursday, and we multiply that by the 0.85 chance of not being late on Friday. So this is going to equal 0.85 multiplied by 0.85. So 1 subtract this. Let's put that into a calculator. So 1 subtract 0.85 times 0.85, and I get 0.2775, 0.2775, and that is my final probability. So final answer there, 0.2775. So about a 30% chance that her train will be late on at least one of these 2 days. And that was question 10 for 5 marks. Question 11 says the grouped frequency table gives information about the times in minutes that 80 office workers take to get to work. So here we have the times and the frequencies. Part A says complete the cumulative frequency table. Cumulative frequency is when you add up the frequencies as you go down the table. So cumulative, you need to understand what that word means. It means basically the running total. How many people in total up to a certain time. So the first one is always the same, 0 to 20. And then the next one we need to add 5 to 30. And then the frequency here from 0 to 40, the cumulative frequency is 35. Then add the 20 on to 35, we get 55. So you can see we're taking the total up to this time, 60. And then we add the 15 on to 55. That's 70, and then we add 8 onto 70, that's 78, and then 2 onto 78 is 80, and you should of course always end on the same number as the total frequency in the problem. So if I ended on 81 or 79, I would know I've made a mistake somewhere. But because I end on 80, I'm fairly confident that I've got them all correct. Okay, so that was part A. Part B says on the grid, draw the cumulative frequency graph for this information. Okay, so for each one, we take the upper bound of the class width and then match it with the frequency. So for 0 to 20, the point is going to be 25. So on the grid, we have 20 as our time in minutes, and then 5 on the cumulative frequency axis. So here it's going to be between 4 and 6, so here, and then the next point was 35. So 40 on the time axis, 35 on the cumulative frequency axis. Next, we have 55. 55 is here. Next point was 70. So 80 on the time axis, 70 on the cumulative frequency axis. And 2 more to go, 178. 78 is here. And then 120/80 is here. Okay, so once you've got those points in, sketch your graph in. It needs to be a curve. You can't just rule lines between the points. You need to try to sketch the curve as best you can. Okay, so starting off at 0, we should have a curve going up like this, and maybe sketch it in with pencil first and then go over it with a pen, or whatever you need to do to make it nice and neat. Then go to the end here, sketch that bit in, just making sure it's as neat a curve as you can get. And there you go, that is my cumulative frequency graph. Okay, part C says use your graph to find an estimate for the percentage of these office workers who take more than 90 minutes to get to work. The way we do this with cumulative frequency graphs is we look at the time, we find 90 minutes on the time axis, and I'll get a different color here, and then go up to the graph. So roll a straight line up to the graph, and then go across to the cumulative frequency axis, and that will give you your estimate. So this is saying below 90 minutes, there's about, what would that be, about 75 people. And the question is saying, use your graph to find an estimate for those that take more than 90 minutes. So the people that take more than 90 minutes are those ones up here. So if this is about 75, this will be about 5 people taking more than 90 minutes to get to work. So that gives me an estimate of about 5 people. But actually this says percentage. So what is 5 out of 80 as a percentage? I need to work that out. This is a calculator paper, of course, so I can use my calculator to get that percentage. All I need to do is 5 divided by 80 and then multiply by 100, and I get 6.25 as my percentage. So actually I should write multiply by 100. And this is, this is an approximation, this 5 out of 80, but my percentage for this calculation is not an approximation. So I guess I should put them there, and then this equals 6.25. And so final answer for me is 6.25%. Now, if you go up to the graph, you can imagine you might get something slightly different depending on how you've sketched your graph. And actually the mark scheme doesn't specify an accurate answer. It says as long as you have an answer that follows through from your graph. So depending on what number you get here, your answer needs to be consistent with that. So if you got 72, you'd still get the correct mark as long as you get the right percentage matching with that value you get there from your graph. Okay, so my answer was 6.25. Again, 3 marks as long as you use the correct method there. It's not really dependent on your final answer. Okay, that was question 11 for 6 marks. Question 12 says OAB is a sector of a circle with center O and radius 7 centimeters. The area of the sector is 40 centimeters squared. Calculate the perimeter of the sector. Give your answer correct to 3 significant figures. For this question, you need to know how to find the area of a sector. And if you know that formula, you know that you usually need this angle in here, the angle of the sector, and you need the radius. They've given us the radius in this question at 7 centimeters, but they haven't given us this angle. So let's just write down that formula, which is something you need to memorize for GCSEs. So area of a sector of a circle is the angle of the sector divided by 360 multiplied by pi r squared. So it's basically the fraction of the circle that you're looking at, or that's how I think about it at least. So here they've given us the area, they haven't given us the angle. So we're going to have to kind of reverse this to find the angle of the sector, and then we're going to be able to find the perimeter. So the first step here would be to say that theta over 360 multiplied by pi r squared equals the area of the sector, which is 40. And actually I could have also included the radius in here, which is 7 squared. So 7 squared, and that all equals 40. We know 7 squared is 49, so I'll just go ahead and write that down quickly. Theta over 360 times pi times 49 equals 40. And now we need to go ahead and solve this equation for theta. So this is about creating an equation and then solving that equation. So you need to rearrange this in terms of theta and get a value for theta. So the first thing I would do would be to divide by 49 or 49 pi and then multiply by 360. So theta here is going to be 40 on 49 pi. So just dividing by these two things here, because I'm multiplying on the left, so you divide on the right, and then multiply by 360, because we're dividing by 360 on the left, so we multiply on the right. And now I can get a value for that angle using my calculator. So I'm going to do 40 divided by 49 times pi. You should know how to find your pi symbol on your calculator, and then multiply all of that by 360, and I get a value of 93.54 approximately. So this is approximately 93.54, and that goes on. Actually, if I put the dots, I don't need to use an approximation symbol. I always do that. I don't know why. So if you put the dots, it shows that the number keeps on going. So anyway, now I have my angle in the sector. So this is about 90 degrees, close to 90 degrees, 93.54. And now I can go ahead and find this arc length AB using the arc length formula. So to find the length AB, so arc length AB, this is going to be the angle of the sector, 93.54, divided by 360, multiplied by the circumference of the circle, which is 2 pi times the radius, which is 7. So that's something else you need to know for GCSEs. You need to know the arc or the area of a sector, and you also need to know arc length, which is very similar. It's theta on 360 times the circumference, which is 2 pi r. So basically, to memorize these, for the area of a sector and arc length, you basically, if you're talking about the area, you look at the area of the circle and multiply it by theta on 360. If you're looking at the arc length, in other words, like the perimeter, then you look at the circumference of a circle and multiply it by theta on 360. For both of these, you're sort of adding in this theta on 360 or multiplying by theta on 360. So that's one way to help to memorize it. Anyways, to find the arc length, we're going to do this calculation on our calculators again. So take that answer, divide it by 360, and then multiply that by 2 pi times 7. And I get 11.42 and so on. 11.428 and so on. Okay, so I have that arc length, and let's go back to the question just to check what it's asking. It says calculate the perimeter of the sector. So I need to add this arc length to these two radii, because that's the entire perimeter around this shape. So 7 plus 7 is 14, so I need to add 14 to this number. So we can say the perimeter then is equal to this answer, 11.428 plus 14. and we're going to round this off to 3 significant figures. So I'll just check my number on the calculator, plus 14, rounding off to 3 significant figures, this would be 25.4. 25.4 to 3 significant figures. So that is my final answer there. And that was question 12 for 4 marks. Question 13 says, show that 6 plus x plus 5 divided by x squared plus 3x take 10 over x take 1 simplifies to ax take b over cx take d, where a, b, c, and d are integers. So we have some algebraic fractions to deal with here. The first step I would take is to deal with this division. So if we're dividing by this algebraic fraction, we can flip it and then it becomes a multiplication. So what I mean is to write this expression as 6 plus x plus 5 multiplied by x take 1 over x squared take plus 3x take 10. So you can see I've flipped that fraction and then now I can multiply these two things. So x plus 5 multiplied by this thing. Next I want to try to factorize this quadratic here. So this x squared plus 3x plus take 10, sorry. So can I factorize this? Are there factors of 10 that make 3? Two factors of 10 are 5 and 2, and they will make 3. So this can factorize to x plus 5 multiplied by x take 2. If we expand that out, we get x squared plus 3x take 10. So I can rewrite this expression again as 6 plus x plus 5 multiplied by x take 1 on the top line, because if we're multiplying these two fractions, writing it this way is the same thing. So whether I include this x plus 5 out the front or in the numerator, it makes no difference. So then I also want to factorize this quadratic to x plus 5 and x take 2. So now you can see there is a common factor in the numerator and denominator. Can you spot the common factor? It's this x plus 5 here. So we can cancel that out. And then we're left with 6 plus x take 1 over x take 2. And we need to keep simplifying because we need to get it in this form. Something x takes something over something x takes something else. So here we need to combine these terms. So how would we usually do this? Well, we multiply this term by this denominator. So this becomes 6 multiplied by x take 2 over x take 2 plus x take 1 over x take 2. Actually, I didn't need those brackets there. Okay, then we can write it all over the same denominator. So this would be, also I'd expand out these brackets. So this would be 6x take 12 plus x take 1 all over x take 2. And then simplifying further, 6x plus x is 7x. Negative 12 take 1 is negative 13 over x take 2. And now we have it in that form where we have something x take something over some 1x take 2. So in this case, A, let me just zoom out a little bit. A is 7, B is 13, C is 1, and D is 2. So that is the final answer there. And that was question 13 for 4 marks. Question 14 says a car moves from rest. The graph gives information about the speed v meters per second of the car t seconds after it starts to move. So let me just zoom out a little bit so we can see the whole thing. Okay, so here we have the speed and the time. Part A, part 1 says calculate an estimate of the gradient of the graph at t equals 15. Whenever you see these words, estimate of the gradient of the graph, you need to draw a tangent at whatever value they're talking about. So we need to draw a tangent to this graph at t equals 15. So t equals 15 is here. And a tangent to the graph is a straight line at that point. So it needs to be like just touching the graph. And you know it'll be okay as long as it's not completely off. Like that is clearly not a tangent, or like this. But if it's like approximately just touching the graph, then it's going to be a pretty good tangent. Okay, so then you need to find the gradient of that tangent by finding the rise between 2 points and the run. And you can pick any points on this tangent. Generally, it makes it easier if you pick whole numbers although for this one I think it's going to be a little bit difficult because of the scale of this axis. But try to find whole number values and it makes finding the gradient a bit easier, but I'm struggling to see any, so I might just pick some random ones. So this looks like it's going through two whole numbers. So what would this number be actually? Actually, we need to figure out the scale first. So this would be 2.5. So this is 1, 2, 3, 4. So every 2 lines is 1. Okay, so this would be 6, 7, 8. So this is 8.5. Okay, that's not very useful, but you know, it's the point I picked. It will do. So this point here is 8.5, and this point on the speed axis is, well, this will be 11, 12. This is 12.5. Okay, and then we need another point on the line. Anywhere is fine. Okay, so this looks like it's going through 2 points. Again, they don't look like they'll be whole numbers, but you just work with what you've got. So this would be 16. So this is 16 and a half. Sorry. No, this is 16, 17, 18. This is 18.5. And on the speed axis, this is 21. So I finally got one whole number. And then you calculate the rise and the run. So basically, you're kind of like drawing a right angle triangle. You need to find this length. This length will be the difference between 21 and 12.5. So what's that? That is 8.5. And this length is the difference between 18.5 and 8.5. Okay, that's a bit easier. That's 10. Okay, now let's do some working out. So we can say the gradient is equal to the rise over the run. The rise is 8.5. The run is 10. So for the gradient here, I get approximately 0.85. And actually, I should use approximation symbols there because it's an estimate. So my estimate for the gradient is 0.85 for 3 marks. And the mark scheme has a range of answers for that from 0.6 to 1. So if you got anywhere in between 0.6 to 1, then you would get those marks, as long as you had the method correct as well. Okay. Part 2 says describe what your answer to part 1 represents. When you're looking at a speed time graph, the gradient of the graph is the rate of change of speed. So what is the rate of change of speed? That's what we call acceleration. So it's how fast you're speeding up. So you could say acceleration, and that is in meters per second squared. You could also say instantaneous rate of change of speed. Okay, either of those is fine, but if you just write acceleration, you'll get that 1 mark. Part B says work out an estimate for the distance the car travels in the first 20 seconds of its journey. Use 4 strips of equal width. So what do they mean by 4 strips of equal width? Well, when you're looking for the distance from a speed time graph, you're looking for the area under that graph. And the way we do this in GCSEs is to split the area up into equal parts. So for this one, I'm going to make 4 strips of equal width as they tell me at every 5 seconds. So the first shape will actually be a triangle because it starts at 0, 0. So that's my first shape. The next one will be between 5 and 10, and then you draw a straight line from the top of each line and you make a trapezium. There'll be another trapezium here between 10 and 15. Again, join them up, and then another one between 15 and 20, and join those up. It's tempting to want to erase your work from the previous question. I would suggest not to do that because there might be marks with that working out on the graph, like drawing your tangent line. You'd need that for part A. So don't erase the work you've already done, even though it looks messy. you might lose marks there. So keep that working out there. And then we need to work out these areas. So actually we need to also draw a line from 0 to the top of this line here. So we have 4 areas here. This area is a triangle. To work out the area of this triangle, we need to do base times height. And you notice you need to find the heights of these lines. So this one is at 4. I've drawn that line a bit off, but that's actually 4 there. So the base is 5, the height is 4. This height is going to be at 12. So this height is 12 of that line. This one is 16, 17, 18. Height of this line is 18. I should have done this in different colors actually. Might make it a bit clearer. And then the final line is at 20, 20. So the height is 20. Okay, let's go ahead and do some working out for these areas. So the first triangle, so I might just say like area 1 or something, just to represent the area. So area 1 was a triangle, the base was 5, the height was 4. So the area of a triangle is base times height divided by 2. That's 10. Area 2, you need to know the area of a trapezium formula. That's height times a plus b, being the top and the bottom. So the height here is 5. So you need to think of these trapeziums as kind of lying on their side. Usually we look at trapezia like this, and that's the top and that's the bottom. And then you have the height, but these are like sort of on their side if you like to think about that. So this is A, this is B, the height is 5, and then we divide that by 2. So we have a height of 5 multiplied by, what would the lengths again, 4 and 12. So 4 plus 12 divided by 2. This is 5 times 16 divided by 2. Why not use our calculator? Just to make sure. So we've got 5 times 16 divided by 2, and that's 40. The next area, area 3, again it'll be the same height for each one, so 5, and then the top is 12, the bottom is 18, so 12 plus 18 divided by 2. This is 30, so it's like 5 times 15, which is 75. And area 4, again the height's the same, and the top is 18, the bottom is 20, so this is 18 plus 20 divided by 2. Again, I'm going to go to my calculator. So what's that? 38 times 5 divided by 2. I get, oops, what have I done? Done something wrong. Oh, I did divide instead of multiply. So 38 times 5 divided by 2, and I get 95. So I found all of those areas. All I need to do now is to add them up. So the total area is all of these added up. Again, just go to my calculator. Why not use it if we can? So adding these up, I get 220. And that is also an estimate of the distance. So my final answer for the estimate of the distance is 220 meters. And that was question 14 for 7 marks. Question 15 says make m the subject of the formula f equals 3m plus 4 over m take 1. So we need to rearrange this formula so that m is the subject. In other words, m is by itself on the left hand side and equals something else. When you have fractions like this, usually the first step you want to do, if you can't factorize, you want to multiply that denominator so that we don't have a fraction anymore. So my first step here is to multiply by m take 1. So then we'll have f times m take 1 equal to 3m plus 4. And then if I can't see anything else to do, expand the bracket. So this will be fm take f equal to 3m plus 4. And then make sure all of the m terms are on the same side together by themselves. So I have a 3m on the right hand side. I want to subtract that from the left and also add this f onto the right hand side. So then I would have fm take 3m equal to 4 plus f. and then factorize an m from both of these terms. So this will be m multiplied by f take 3 equal to 4 plus f, and then divide by f take 3, and I'll be left with m equal to 4 plus f over f take 3. And we have rearranged this formula so that m is the subject. So final answer there is m equal to 4 plus f over f take 3. Whoops. F take 3. And that's question 15 for 3 marks. Question 16 says the straight line L has the equation 3y equal to 4x plus 7. The point A has coordinates 3, negative 5. Find an equation of the straight line that is perpendicular to L and passes through A. A couple of things I want to do before I start this problem. I want to rewrite this equation here so that it is y equal to 4 on 3x plus 7 on 3. That might be the formula more familiar with. This is like y equals mx plus c. So then we can know that the gradient of this line is 4 on 3 straight away from this equation. And we also want to note that when we know two straight lines are perpendicular, meaning they're at right angles, their gradients are negative reciprocals of each other. So if we make a note that we know the gradient of L is 4 on 3 from this equation, we also know the gradient of the perpendicular line, is the negative reciprocal. What that means is you take this fraction, whatever it is, you flip it, and you make it a negative. So it's going to be negative 3 on 4. That's something you need to know for GCSEs. So we know the gradient of that line. We also know a point on the line because it says it passes through A. And they tell us the coordinates of A. So if we know a point on the line and we know its gradient, we can use the point slope formula to find the equation of the line. The point slope formula looks like this. It is y take y1 equal to m times x take x1. This is called the point slope formula. Okay, this y1 and x1, they are this point here. So y1 being negative 5, x1 being 3. M is the gradient, just as in y equals mx plus c. M is negative 3 on 4. So we plug those things into this formula and we end up with our equation. So we have y take negative 5 equal to negative 3 on 4 multiplied by x take 3. Okay, and then we just simplify this. So take negative 5 is y plus 5. And expand out these brackets, we have negative 3 on 4x plus 9 on 4. And then simplify further. So we need to get rid of this positive 5. We subtract it from the right hand side. This is y equal to negative 3 on 4x plus 9 on 4 take 5. Let's do a little bit of notes over here just to be clear. 9 on 4 take 5. That's like 9 on 4 take 20 on 4. This is negative 11 on 4. So this simplifies to negative 11 on 4. And that's the equation of our straight line perpendicular to L. So final answer, y equal to negative 3 on 4x take 11 on 4. That was question 16 for 3 marks. Question 17 says there are some small cubes and some large cubes in a bag. The cubes are red or the cubes are yellow. The ratio of the number of small cubes to the number of large cubes is 4 to 7. The ratio of the number of red cubes to the number of yellow cubes is 3 to 5. Explain why the least possible number of cubes in the bag is 88. This is to do with these ratios and the number of parts in each ratio. So the number of parts in this ratio is 4 plus 7. So that's 11 parts. And the number of parts in this ratio is 3 plus 5. That's 8 parts. And you need to think about what these ratios mean. So because we're talking about cubes, they're individual objects, we need to have whole numbers. we're not going to have fractions of cubes. It's just cubes, like 1 cube, 2 cubes, 3 cubes. They're whole numbers. So the way that we work with ratios is that to get the actual number of cubes, we'd multiply these by some number, because these ratios are representing the same number of things. Whether they're small or large or red or yellow, it's still the same number of cubes. So whatever we multiply these ratios by, the number of parts will eventually have to be the same. And so what we're actually looking for is the lowest common multiple of 11 and 8. So to answer this question, we're saying the lowest common multiple of 11 and 8. That's what we're looking for. And because 11 is a prime number, the lowest common multiple is 8 multiplied by 11. So it's 88. That's why 88 is the least possible number of cubes. This is actually kind of a confusing question, and I'd understand if people are not quite understanding what's going on here. So what I'd suggest to understand this question is actually to get some cubes with different colors and different sizes, or to make a drawing. Let's say you draw some circles, like 4 small circles, 2 large circles, color some of them in, and just experiment with the ratios and see what the ratios are and how the ratios compare to the total number of objects you've drawn, and hopefully it starts to make sense. But this is basically all you need to say to answer this question. The lowest common multiple of 11 and 8 is 88. Okay, on to the next part. Part B says all the small cubes are yellow. Work out the least possible number of large yellow cubes in the bag. So to start off this question, what I want to do is actually to use part A. So I'm going to rewrite these ratios again. So we've got small cubes to large cubes. Large cubes. That ratio was 4 to 7. That's straight from the question, remember? Small cubes to large cubes, 4 to 7. And the ratio of red to yellow cubes, this was 3 to 5. Again, straight from the question. And now what we want to say, well, let's say there were 88 cubes in the bag. What would these ratios actually be? Remember we said we need to multiply 8 and 11? So this one we're multiplying by 8 because they added up to 11. So I'm multiplying this ratio by 8. So each number I multiply by 8, so 4 times 8 is 32. 7 times 8 is 56. This one I'm multiplying by 11 because these added up to 8. So this is 3 times 11 is 33. 5 times 11 is 55. So these are possible ratios of the actual number of cubes. So the actual number of small cubes could be 32, and the actual number of large cubes could be 56, because these add up to the same thing. And remember in part A we said this is the least possible number of cubes, so these are the smallest possible numbers we could have. The smallest possible number of small cubes is 32. The smallest possible number of yellow cubes is 55. And they tell us here that all small cubes are yellow. So if we look at this number here, 32, that represents the number of small cubes, and we also know they're all yellow. So how many of the yellow cubes are large? It would be the difference between these numbers. So we take the number of yellow cubes, the smallest possible number of yellow cubes. So actually let's write that down. Smallest possible number of yellow cubes is 55, and we take 32. So 55 take 32, and that gives us a difference of 23, and that's the answer. So this is the smallest possible, or the least possible number of large yellow cubes in the bag. So final answer there is 23. And that was question 17 for 4 marks. Question 18 says the points A, B, C, and D lie in a circle. CDE is a straight line. BA equals BD. They've marked those in. CB equals CD. They've also marked those in. Angle ABD equals 40 degrees. They've marked that as well. Work out the size of angle ADE. You must give a reason for each stage of your working. we are looking for this angle here. What's going to help me to find that angle is if I could find these two other angles. Because CD is a straight line, if I know this entire angle here, I can work out ADE based on the fact that angles on a straight line add up to 180. So what I'm aiming for here is to find these two angles in here. Firstly, I know what this angle is going to be because this is an isosceles triangle and the base angles in an isosceles triangle are equal. So I can work out BDA. So angle BDA equals angle BAD because that's isosceles. And this would be, well, you can do the whole working out if you want. This is 180 take 40, the other angle in the triangle, divided by 2. So this is 140 divided by 2, which is 70 degrees. So in here, this is 70 degrees. And this is based on the fact that base angles in an isosceles triangle are equal. So when it says you must give a reason for each stage of your working, make sure you're including some explanation as to why you're doing what you're doing. Next, remember I said I'm looking for this little angle in here as well. I can find that angle if I can find this angle up here, BCD. And I can find that angle based on the fact that opposite angles in a cyclic quadrilateral add up to 180 degrees. So I know this angle over here is 70. I just found that. So these two angles need to add up to 180 degrees. So I can find angle BCD using that idea. So angle BCD is equal to 180 take 70, which is 110 degrees. This is opposite angles in a cyclic quadrilateral, and this is one of the circle theorems you need to know. If you want to revise all of the circle theorems and the proofs, check out my video going through all of the circle theorems. So now we know this angle up here is 110 degrees. Again, this is an isosceles triangle, so I can use the fact that base angle is equal again to work out this little angle in here. Okay, so I'm looking for BDC now, this little angle. So angle BDC is equal to 180 take 110 divided by 2. This is 70 divided by 2. This is 35 degrees. And then again, this is base angles in an isosceles triangle. So now I know this whole angle here, or at least I know these two angles, 35 and 70, they add up to 105, and I can work out ADE. So here I can say angle ADE equals 180, angles on a straight line, or degrees on a straight line, take 70 plus 35. That's going to be 75 degrees. So this is angles on a straight line. Okay, so final answer is 75 degrees. And that was question 18 for 5 marks. Question 19 says the diagram shows a triangular prism. The base ABCD of the prism is a square of side length 15 centimeters. Angle ABE and angle CBE are right angles. Angle EAB equals 35 degrees. M is the point on DA such that DM to MA equals 2 to 3. Calculate the size of the angle between EM and the base of the prism. Give your answer correct to 1 decimal place. So they haven't drawn M on the diagram, so let's go ahead and do that first. So M is a point on DA such that DM to DMA is 2 to 3. So M will be somewhere about here, so that this is 3 parts of that line and this is 2 parts. And we need the angle between EM and the base. So we need to draw in EM. So E is up here. So that's EM. And we need the angle between that line and the base of this prism. So we also need to draw in a line from M to B, so that we create a right angled triangle in there with an angle between EM and the base. So this is the angle we're looking for. So what this is going to involve is finding the length of MB and then using our trig ratios to find this angle in here. So firstly, to find MB, I want the lengths of this triangle MAB. So you really need to think three-dimensionally here. This is like a flat triangle lying on its side, but it's still a right angle triangle because this angle MAB is 90 degrees in here. So this is actually a right angle triangle lying flat on the floor. I know it can be confusing to think about. Really try to think three-dimensionally. If you want a solid shape in your hand to help you think about it, you know, cut out a slice of cheese or something, I don't know, find something in this shape or a door wedge or something, maybe that can help. But I have the length AB, which is 15. I want the length MA. Well, if it's 3 parts of 5 parts and the total length is 15, I can work out MA. So in other words, what we're saying, it's MA is 3/5 of 15 centimeters. That's a 5. So this is 15 divided by 5 is 3, times 3 is 9 centimeters. Okay, so that's using this ratio 2 to 3. So MA is 9 centimeters. MB then, using Pythagoras Theorem, this is the hypotenuse. So this is the square root of 9 squared plus 15 squared. Let's put that into a calculator. Okay, so the square root of 9 squared plus 15 squared. This is 17.49 and so on, 17.49. Okay, so I have that length MB. To find this angle in here, I need another side of this right angle triangle MBE. So I could either find the hypotenuse or EB. I think EB will be easier. We can find EB using this angle 35 degrees and this side AB. So if I have an angle and one leg, I can use the tan ratio to work out the other leg. Remember, the tan of an angle is the opposite side over the adjacent side. So you rearrange this, you can say that the opposite side is equal to the tangent of the angle times the adjacent side, which is 15. So here we can say EB, the side length EB is equal to tan of 35 times 15. So let's go ahead and work that out. So we want tan of 35 multiplied by 15. I get 10.5 and so on. 10.5. So going back to the diagram again, I have EB, which is about 10.5. I have MB, which I worked out to be 17.49 of this right angle triangle. Again, this would also be a right angle triangle MBE because EB is perpendicular to MB. And then I can use the tangent ratio again because I have the opposite side and the adjacent side to find that angle. Okay, so the tangent of theta equals EB, which was 10.5, divided by MB, 17.49. And then I want the inverse tangent of that fraction to work out the angle. Okay, so then we're going to put this into a calculator and it will do its magic. Okay, so the inverse tangent of the previous answer divided by 17.49. I'm going to put in 5 of those decimal places. That will give me enough accuracy. So 49285. And I get 30.98 and so on. And the question says give your answer correct to 1 decimal place. So if I was rounding this off to 1 decimal place, that 9 would round up to 10, so I'd actually need to carry 1 over. So this would be 31.0 rounded to 1 decimal place. So this is approximately 31.0, and that is in degrees. So also remember to include that 0 in your answer. If it says to 1 decimal place, whatever that decimal place is, include it in your answer, otherwise you won't get the full marks. So 31.0, that's my final answer for question 19 for 4 marks. Question 20 says CDEF is a quadrilateral. CD, the vector CD equals A, the vector DE equals B, and the vector FC equals A take B. Part A says express FE in terms of A and or B. Give your answer in its simplest form. So we're looking for this vector FE. Let's go ahead and label these vectors. So CD is up here, that's A. DE is over here, that's B. And it's in this direction. Okay, and FC is A take B in this direction. And we want the vector FE, so what we want to do is take a little journey around the vectors that we have from F to E. So we can say FE is equal to A take B, this vector, from F to C. So A take B plus C to D, which is A, plus D to E, which is B. Okay, so we took a little walk there around the vectors that we have from F to C to D to E, adding those vectors as we went, and now we have the vector FE. And now we need to simplify it. So A plus A is 2A, and negative B plus B, they cancel out. So we're just left with 2A. So FE is going to be 2A. Alright, so that's part A. Part B says M is the midpoint of DE, X is the point on FM such that Fx to Xm equals n to 1, CXE is a straight line, work out the value of n. I'm going to be honest with you, I don't really like this question, but actually I found a fun way to answer it that is not in the mark scheme. So first I'll go through the solution that matches up with the mark scheme, and then I'll go through a bit of a different solution which I feel is a little bit simpler. So anyways, M is the midpoint of DE. So let's go up to the diagram and mark some of this information in. If M is the midpoint, that means DM is half B and ME is half B. So M to E is half B. And this line, FXM, is split up into the ratio n to 1. And CXE is a straight line. So let's go ahead and draw that in as well. Okay. Alright, so the solution here is going to involve finding a vector for Fm and then finding a fraction of that related to Fx. So firstly I want Fm in terms of A and B. So how do we get from F to M? Well, remember we said Fe is 2A, let's label that as well. So F to E is 2A, and then E to M is negative half B. So Fe is going to be 2A take half B. So let's go ahead and write that down. So Fm is 2A take, 2A take half B. And I also want an expression or a vector of Fx in terms of A and B. Or you can also do Xm. So I'm going to choose Fx, but just be aware there's a couple ways to do this. You can do Fx or Xm. So Fx is, if we look at this line, the fraction of this line is actually n over the total length of the line. So the total length of the line is actually n plus 1. So Fx, we can say, is n, the fraction of that line out of the total length, which is n plus 1, parts of Fm. Okay. It's important to understand that step, why it's n over n plus 1. Hopefully that makes sense. And so then we can say Fx is n over n plus 1, lots of 2a take a half b. Okay, so we have an expression for Fx in terms of a and b and n. Now we're going to use the fact that CXE is a straight line, and also we can find CE in terms of a and b. So CE is a plus b, so let's write that down first. So CE, the vector CE is a plus b. Now notice something about this vector. The coefficients of a and b are the same. They're both 1. And for any part of that line, so looking at the diagram again, for any part of that line, the coefficients for the a and b parts of the vector need to be the same. So if I looked at XE, then the vector parts related to A and B, they would need the same coefficients. That's really the key to answering this question, realizing that idea. So basically we're talking about scaling things up and down. This is something you need to know about vectors. This is expected knowledge in GCSEs that, vectors that lie parallel or on the same line, they have the same scalar multiple. Okay, so we know CE is A plus B. Then we need to find either CX or XE. You can do either one, just as we could find FX or XM. You can use either part of that line. I'm going to do CX, but really it doesn't make much difference whether you do CX or XE. Anyway, CX, what could we say? We could say it's A plus half B plus this part. But because I've already found FX, I'm going to go this way. So CX is CF to FX. So I need to find the vector CF. So let's go ahead and do that. So CF is the negative of FC. And remember, FC is A plus B. So the negative of that is B take A. So then CX is B take A plus FX. I have an expression for FX here. I add that on. And I have CX, so this is n over n plus 1 multiplied by 2a take half b. Once you get to this point, you're about halfway there. You need to simplify this expression, so combine like terms. In other words, I want to expand these brackets and then get the a parts of the vector together and the b parts together. So I'll expand these brackets first. This is going to be n over n plus 1 times 2a, that's 2n over n plus 1a. And n over n plus 1 times negative half is negative n over 2 times n plus 1b. And this is where it gets really messy algebraically. There's lots of fractions and things you have to deal with. That's why I don't really like this question, but you have to kind of get through this part and figure all this out. So here, again, combining this stuff, I've got a negative a plus 2n over n plus 1a. You can write this as 2n over n plus 1a take a, and then over here I've got a plus b take n over 2 times n plus 1b. Here we need to, factorize out the a here. So this is going to be 2n over n plus 1 take 1 a. And then here we need to factorize out the b. This is 1 take n over 2n, 2 times n plus 1 b. Once you get to this point, you can say that these coefficients need to be equal. Remember, that was the point I was making before, because CXE is a straight line, and CE, its coefficients are equal. So let's just make a note of that. This is equal coefficients. So because they are on the same straight line, these coefficients also need to be equal. So then you can say that 2n over n plus 1 take 1 equals 1 take n over 2 times n plus 1. Okay, then you need to solve this for n. From here, there's a number of things you could do. It's hard to say which is the simplest or the fastest way to do it. I would probably start by adding that 1 to the right hand side. So this is then 2n over n plus 1 equal to 2 take n over 2 times n plus 1. With this expression, what makes it difficult is this 2 here. You can't really do anything with that 2. It's hard to solve for n with that 2 there. So you can do something a little bit tricky here. You can multiply everything by 2 to get rid of this 2 down here. So this would be 4n over n plus 1 equal to 4 take n over n plus 1. So I've multiplied everything by 2. And then multiplied this constant by n plus 1. So this would be the same thing on the left hand side. Leave that as is. And I'm just multiplying this 4 by n plus 1 over n plus 1, and this is subtract n over n plus 1, and then because they all have the same denominator, we can just equate the numerators. if they all have the same denominator, they effectively cancel themselves out. So this is then 4n equal to 4 times n plus 1, take n. And then solving this for n, we've got 4n equal to 4n plus 4, take n. And then hopefully you can see n equals 4. Okay, because that 4 take n, that needs to be 0 for 4n to equal 4n. So final answer there, n equals 4. So a lot of algebra there. There are multiple ways to answer this. There's probably a neat way to solve that algebraically. So don't just take this method and say, this is how I'm going to do it. Look for a better way to do it. Look for a more efficient way to do it, which is what I did with the whole question. So let me go ahead and show you how I would answer this question. Maybe a bit neater, a bit simpler, at least I think so anyway. So going back to the diagram, I'll keep most of this notation actually. But what I want to do is draw a little parallelogram in here. Okay, so from X I've got two lines. This line is parallel to CD, and this line is parallel to DE. In other words, they're parallel to these vectors A and B. And I want to draw your attention to this segment, line segment XE. And because I know the coefficients of A and B need to be equal, I could call this section KA. So this is some multiple of A just shrunk down, K being some scalar multiple. This section here, I'll call this point N. This section NE, I'm going to call KB. Okay. So what I'm saying is XE equals KA plus KB. So I'll just write that down. So XE equals KA plus KB. And then also notice, because this line XN is parallel to FE, this line here, I'll call this point Y, XY is also KB. Okay. And then I want to draw your attention to two similar triangles, these two here. Okay, so these are similar because all of the angles are the same, because all of the lines are parallel, right? So, and also FXM is a straight line. So these two triangles are similar. That means that whatever I scale up this section by, XM to FX, I need to scale the other sides up by the same thing. So XM, we've called 1, it's now N. So this section here, XM, has become N. So my scale factor is N. Okay, so the scale factor between these two similar triangles is N. So I'm multiplying by N. That means that I need to scale this line, XN, up by the same thing. So FY, I could call NKA. Alright, so FY is NKA. And now I want to draw your attention back to these vectors, half B and 2A. So the ratio between the coefficients of 2A and a half B needs to be the same as NKA to KB, because they're similar triangles. So what I'm saying here is that FY, the vector FY to XY, needs to be in the same ratio as FE to ME. And I know FE to ME is 2A to a half B. And I could write that even simpler using equivalent ratios. I could say this is 4A to B. Okay, so what I'm saying there is that the ratio 2 to a half is the same as 4 to 1, right? That's equivalent ratios. That's primary school stuff. You should be comfortable with that idea. I can multiply this by anything. I can multiply it by 10. 40 to 10, it would still be the same ratio. So FY to XY is equivalent to 4A to B. And now FY to XY, remember I've labeled those vectors, NKA and KB. Okay, so let's say NKA to KB is equivalent to 4A to B. And now Well, those k's, they're like a common factor. I can effectively cancel those out. They don't really need to be there. Okay, so we're just talking about the ratio NA to B is equal to 4A to B. Well, here clearly N equals 4, right? NA is equal to 4A, N equals 4. So that's a bit of a simpler method. I think that it's a bit harder to see that maybe, like you have to draw in these lines and you have to look at similar triangles and things, but the working out is, in my opinion, much neater. So anyways, that was my method that I found that was not in the mark scheme, so I'm not sure whether I can recommend it, but maybe it's something they missed when they were writing the mark scheme, that you can solve it in this way. There's absolutely nothing wrong with it. This is absolutely fine mathematically. So there you go. It kind of avoids all that algebra that I was doing before in the last solution. Anyways, that was question 20 for a total of 6 marks. That's the end of this paper. I hope you found it useful. Please leave a like if you did, and I'll see you in the next one. Bye for now. Also, don't forget to check out Easy A. The link is in the description. All right, thanks for watching.